Hello, welcome back to Cracking the Cryptic, and well, an absolutely fascinating looking puzzle today. Now, I don't know what is going on here, but I may be running a little short of time today, so if this gets interrupted, you know you can blame Simon, because not only did he say he wanted me to have a go at this puzzle today, he also then talked to me on the phone for ages and has left me very little time before the point at which I do not want to leave my daughter at school, so because she has to be picked up. So I'm going to have a go at this. I may have to interrupt it in about 40 minutes if it's hard, and apparently it might be. So really interested in this puzzle. I've also made a number of mistakes over the last few days. Got to the mildest one yesterday with a typo in the puzzle title, so apologies to Mr. Mo for that. I misprinted magic. But anyway, there's no doubt something like that going on again today. But we'll have a look at this in a moment. Still on Patreon, of course, our February reward, the Quite Approachable Sudoku. We've also got 2 sets of the videos for $3 a month patrons. We have 2 sets of trilogies of videos showing the solutions to Peter C. Hayward's brilliant January puzzle hunt. The 3rd will come up in a few days, I believe. And other stuff on Patreon includes, there's a free video of Simon solving a very interesting puzzle. Or in fact, yeah, I mean, there's some interaction between him and Fistamafel, which is very interesting about a puzzle he did on the channel. There's also his riposte to me solving a Fistamafel puzzle on Patreon. That's for the paying patrons, where he explains a better way of solving it, which is typical, but I absolutely respect that. So let's hope I can solve this in a way that doesn't require either me to have to explain what I did wrong or Simon to come back and explain what I could have done better. We shall see. Give it my best shot. Now, this is called Kropki X Sums by Spartacus, and I believe it's made a list of Zotomath's favourite puzzles of some period. And I just love the look of it. So, normal Sudoku rules apply. White dots separate 2 consecutive numbers. There, for instance. Black dots separate 2 numbers with a ratio of 1 to 2. I can highlight that pair. Not all dots are given. Numbers outside the grid, which must be deduced, indicate the sum of the X first digits in that row or column, seen from the direction of the clue, where X is the first of those digits. So if, for instance, this row from the left began 326, then the X sum clue this would get outside the grid, if it had one, is the sum of the first 3 digits from this direction, which in this case would be 11. So it would say 11 outside the grid. Now what's happening in this puzzle is some of the dots are outside the grid or on the edge of it, and therefore, there are numbers that we have to imagine outside the grid that are the X sum clues. And goodness knows, obviously there are ratios of 1 to 2 where there are black dots. Remember, these could be 20 and 40 or something. They could be very high numbers. The white dots could be separating, well, I suppose, why not 33 and 32 or something. Actually, there probably is a reason why not, but big numbers they could be involved, or small numbers. There's some on the edges of the grid down here. Now, the grid I'm providing here, the grid I'm solving off, I'm going to have to imagine the numbers outside the grid. I might also, if I remember and if I have time, give you another grid where you can write the numbers in on the outsides of the grid, but the check function won't work, I imagine, with that. I will try and provide that, and also you won't be able to write double-digit numbers outside the grid anyway, because our software doesn't allow it. So there are limitations on what one can do. So I'm going to go with the maximally limited version and see how we get on. I mean, I'm fascinated. What a brilliant presentation of a puzzle, that this can exist with this few clues and no digits anywhere inside or outside the puzzle. Brilliant. Anyway, really looking forward to it. Given you the warning about 40 minutes time. I'm going to get cracking now, see if I can get done in that time. Let's get cracking. Let's go. So you can try it on the link under the video, of course. So look, these ones on the perimeter, this black one looks promising. We surely have to have the smaller number of the pair on the inside. And I don't think this can be 2, 1. 2 on the outside, 1 on the inside, because that would be incorrect. The 1 would mean it was adding only 1 cell. If it was a 4 outside, that's not working as well, because if you had a 2 here, 2 cells wouldn't add up to 4. 6 and 3 would work. You'd have to have 2 and 1. 8 and 4 wouldn't work, because that would be saying that you'd be adding 4 cells to get to 8, and you can't do that. So there is only one option. It's 3 with a 2, 1 pair to make a 6 outside the grid, but you will have to imagine, as I will. So that is a start. Now, these two can't use 3, 2, or 1, so they are a 4, 8 pair. That has to be right. And I've got a number in the grid and a couple of pairs. I'm feeling quite good about that straight away. Now, one of these numbers is counting 8 digits, and one of them is counting 4, and they're giving totals that are in a similar relationship. That's a pity that the one that's giving 8 digits must be double the one that's giving 4. Yeah, it must be. That's clear. And the one that's giving 8 digits is even. So the one that's giving 8 digits has an odd number at the end of the row. And that's because, so wherever there's an 8 in one of these two cells, there's an odd number over here. And I know that because of the rule of 45. The numbers in each row add up to 45. If you take off and because the larger number here must be even because it's twice the smaller number. So if you take off even from 45, you get odd. So it's not that useful a conclusion, but I'm just explaining how I've reached it. I mean, there's nothing. Does this white help? Oh, maybe it does. For these to be consecutive. Oh, yes, I think this is useful. I kind of feel it. Obviously, the smaller number must be on the inside again because you're adding up to the bigger number then. You can't have a larger number inside, just as over here. You can't have a larger number on the inside and a smaller one on the outside because the larger number would break the total already. So the smaller numbers on the inside, if they're consecutive, the rest of the sum is a single one. So that goes there. I was going to say that it must be 2 here and 3 outside. Yes, that is right, because you're adding 2 digits. So it is that, 2 there and a 3 outside the grid. And if that's even, that's great. Then my deduction about 8 and 4 is working. This can't be an 8, because the first 8 would add up to 33, but 33 would be double 16.5, which is impossible. So that's the 4, and that's the 8. And then we have an odd digit here. And these 8 add up to either 36, 38, 40, or 42. So these 4 digits add up to 18, 19, 20, or 21. I don't think that's actually very helpful. 4, 5, 6 wouldn't work because you'd have a 6. 4, 5, 7 would need a 5. Actually, they don't work. 4, 5. They don't work. 4, 5, 9 would need a 3. That is possible. 4, 6, 7. I might as well run through these because I don't think I've got a lot to go on. 4, 6, 7 would need a... Oh no, what am I doing? I'm coming to one of the totals. That's absolutely stupid. Okay, let's just think again. What were the numbers I said? I said 42, 40, 38, or 36. So 18, 19, 20, or 21. 4, 5, 6 could go with a 3 and make 18. Now, there must be a host of possibilities here. 9, 7, 4 is 20. That would need a 1. Okay, I'm sorry. I'm going to run through these possibilities. 4, 5, 6, 3. That is possible. But it is also possible that if you go higher than that, we're just breaking it down. 754 is, I've done the maths wrong. 456 to get to a maximum of 21. Oh, I see. 4563 would make 18, which is possible. 457, which is 16, would need a maximum of 5, and that would have to be 3 again. 459, that's probably too many. 18. No, again, you could do it, but with a 3. So if you didn't use a 5, 467 is 17. And 5 would be too many. So again, you'd get a 3 here. 469, I have a feeling this is all going to be the same. Oh, 469 is too much. You're already up to 19 and you're going to break 21. So that is a 3. But these either involve a 5 or a 6. 459. They could even involve a 9, so I can't rule anything out of those. Wow, I mean, that's quite complicated to get to not much information there. Can I use this? Oh, this black dot? No, I mean, that's just describing 2 sums up here. Although it's interestingly poised opposite another black dot. I don't know how to use those. I don't even think I can imagine how to use those. Can I use this white dot? Oh, and it's next to another one. So there's 3 consecutive numbers outside here. And this is a... right, if that was a 9, I think this won't work. Then this would add up to 45. That can't be a sum of 44 because there's not a 1 on the end. So that's not a 9. If it was a 7 even... well, those are quite big, so that might work. If it was a 7, we're adding up to somewhere between 32 and 28. Then this could be 27. Actually, they're very small, so that could be 27 by being a 5 at the beginning, or even a 4 perhaps. And this would be 26, and again, that could be a big number. So these just have to be in the same sort of ballpark, and that seems very manageable. If this was a 3, then the most these could add up to is 19. 20 here with at least a 4. Yeah, that's possible, and that could be a 5 for 21. Yeah, I don't think I can narrow that down any further, which is a shame. Now, these digits are from 5, 6, 7, 8, 9. Now, if there was a 9 here, that would be on the bigger black dot, but it would also have a total of 45, which couldn't be twice the smaller black dot, so there isn't a 9. So they're from 5, 6, 7, and 8, and one is giving half the total of the other. Well, the minimum you can have with 8 is 36. The maximum you can have with 5 is 35, actually. But if you had 36, then you'd have another black dot of 18. And 6 would be too many. So let's rule out 7. The maximum as the larger number of these two. If you had a 7, its total would be somewhere between 28, which is a good number, 28 and 42, giving you a total on the other number of somewhere between 14 and 21. But 5 is too... it's too big for 14, but it's not too big for 21. So I don't think we can rule out 7. Even 6 could be 21. You could have a 6 giving 21 and an 8 giving 42. In fact, the 8 could give 44. And the 6 could give... I don't think 6 can give 22, but it can give 21. Oh, okay. I can't rule either of those out. That's annoying. Now this is a pair that don't involve 3, 4 or 8. They've got to have an odd digit. So it's either a 2-1 pair or a pair involving a 6. Oh, this is what I'm reduced to, is trivial and useless deductions like that. I suppose, okay, we took the 9 out from here. So this is reduced to 42, 40 or 38. So this group of cells adds up to 19, 20 or 21. So these two add up to 12, 13 or 14. Only those totals. 12 would be 5, 7. 13 would be 6, 7. 14 would be 5, 9. So the 5, 9, which would make 14, would go with this being a 3. There is going to be a 3 here. And I can put 1, 2, just by Sudoku. I'm noticing they go in there somewhere. 3 does go in one of these 3 cells, so it's got a fair chance of being in there. I just don't think I can do any more with that. I mean, there are only 3 combos of these numbers, but they use all the possible numbers, so it's not all that helpful. These I thought were going to come down to an 8 and a 5 for definite, but that is not definite, because you could keep a 6 total very low and get a 7 total quite high. I mean, it would be great if we could prove this was a 6 and a 7, because the 6 would have to be 21 and the 7 would have to be 42, and that would actually be very helpful because they'd have fixed sets, but there's no way of knowing that at the moment, unless the fact that they're opposite 2 numbers. I just don't think that helps yet. I can't see how it does. And the positions of these black dots outside the grid and that white, how are they helping us do anything? Really need to think of something to do here. It's very hard indeed. Maybe it is this run of 3 again that I disdained before. Crumbs, I just don't know what to look at. 8, 1, 2. So these are adding. I don't know. 13, 32 is the maximum they can be, but that's a big number. And the minimum we could have here is 3, 4, 5, I suppose, which is 12. Now I can see that's too small because then you couldn't get 13 out of 4 cells here. In fact, that has to be at least a 4. And the 4 cells it has to be add up to at least 4, 5, 6, 7 is 22. Oh, that's interesting. Okay, so this number has a minimum 22. So this has a minimum 21, and that can't actually be a 3 anymore. Interesting. Okay, well that's better than I was expecting. Now, if this was 6, 7, 8 or 9, the total would be at least 39. And then, or something bigger up to 45. Now, if that total was 39 outside the grid, could this possibly be 38? No, it couldn't, because then you add on that number and you're already up to 46. So this can't be as high as a 6. This is 3, 4 or 5 there. No, it's not 3, because that's already in the row. Okay, so if this is a 5, that's a 7. And then we are getting a sum of somewhere between, what were the numbers I said, 28 to 32. Then this would have to be 4 or 5, and if that was a 5, this would be 5 cells adding to somewhere between 27 and 33. 33 is possible if you had a 6 there and another 6 in total there. But it's actually reduced more than I thought now. 4 and 7 would be difficult. 7, so we're saying, I'm now wondering if one of these has to be a 5, which isn't a huge advance if it's true, but I'd still like to know. If they weren't 5s, we'd have a 4 here and a 7 here. The 7, again, would add up to somewhere between 28 and 32. And this would have to add up from somewhere between 27 and 33. Can you do that in 4 cells? Yes, 4, 9, 8, 6. Bother. Right, but we removed the 3 here, so these don't add up to 42, so these don't make 21. They either make 20 or 19. These two add up to 13 or 12. So they're either 6, 7 or 5, 7. Oh, well, that's interesting. So there's no 9, and they've got a 7. So here we can't have a 7 in those cells. Here we can't have a 7 in these. And this has got tighter. Now, do these definite... Oh, well, these don't have a 9 and those don't have a 9, so we can place 9 in the bottom row. Good grief. One of these is an 8, but that can be with a 6. We worked that out earlier. That's not actually that helpful. Oh, this is fascinating, actually. So, if this was 4, 6, 7, 3, which is one of the possibilities, that would force this to be a 5, 9 and make this a 7. So what's happening there? If this is 4, 6, 7, 3, then it makes 20. You put 6, 7 here, but this makes 40 and you get 5 here and you need 6, 9 here. That's not going to work. We can't have 6, 7 here and 6, 9 here. So it's not 6, 7 here, so it's 5, 7 here. Wow, and we can deduce what it is. And this is an 8, 6, 9 pair. Right, and this total now, we now know it is, adds it up again, 19. So this total is 38, and that is a 7. And that is the bigger number. Now, these 7, we're down to 2 possibilities for that. So they add up to either 31 or 28. So these 4 or 5 cells add up to 1 away from 31 or 28. They add up to 32, 30, 29 or 27. But let's do some Sudoku. We've got a 9 there and a 9 there. So there's definitely a 9 here. There's definitely a 3 here. There's definitely a 7 up there. 3. And does that affect what this total can be? It's going to include a 9, but I think it almost had to. If it was 5, right. Now, I'm going to have to keep remembering what I said this total was. It's either 28 or 31. So, this is 1 away from 28 or 31. If it was using all 5, which is likely actually, then the outies, these would add up to 45 minus 28. Oh, basically, they'd add up to the total of these plus or minus 1, which is 14 plus or minus 1 would be the same here. So that would be a 7 or a 9. Well, it would have to be a 7. Or to get to 21, no, 14 or 17. To get to 17, well, you'd need a 10 or a 12. Wow. So if that's a 5, that's a 7, apparently, by the maths I just did there. And if that's a 4, Didn't we need 986 here to make 27? So this could be 28 with a 9 there. I think we did. Yeah, we can't make 28. It would have to be 27. 4986. And this would be a 7-5 pair. So 7 can never be there. How weird. So either there's a lone 7 there or a 7-5 pair, I think. 7-5. No, that would be allowing the 4 here. That would be 6 or 8 in that version. But in the 5 version with the 7 here, then it would be 4, 6 or 8. So it's certainly one of them. I just don't think I can reach more conclusions until I know something either about this cell. Well, okay, it's the same parity as this. Now this adds up to either 28 or 31. This is 2, or it could be 28 or 31 again. I suppose these consecutives could go down and back up, but it could also be 26 or 24, 30, 29 or 33. It's not very helpful. It really isn't. But the trouble is, I'm just absolutely no idea how to get into the rest of the grid from these bottom rows where we've at least had some clues. Oh, 5, 7 pair. That means this is now a 6 and an 8. Well, that does take us to what I said. Right, the 6 is a minimum of 21. And with a 6 in it, it can't be 1, 2, 3, 4, 5, 7, which is the only way you could make 22 in 6 digits. So the 6 is in a 21, a 5-digit thing, a 6-digit sum that adds to 21, which is 6, 5, 4, 3, 2, 1. And the 8 makes 42, and one of these top two is a 3, which is the outie in the column with the 8 in. Good grief. Okay, well, this is where we're going next. There's nowhere else to go. So the 6 has a 987 outie set at the end of the column. So one of these groups of cells is 987, and on the other side there's a single 3. Now, if 987 was here, with the 6 here, then what? Then these would be from 3, 4 and 5. And they'd include the 3. So 987 would be here, 6 here, 3 would be there, that would be 4 or 5, and this would probably be 1, 2. Actually, it could be, no, it couldn't be 4 or 5, it would be 1, 2. So that does just work with the 987 there, which is a shame. I wanted to eliminate that one. But if it's 987 here, we have 6 here, 4 here, and then we have 1, 2, 3, 5 spread out amongst those cells. That's fine. Oh. Come on, there must be a way of working out which is which. Oh, well, I haven't thought about the consequences of 3 cells and 7 cells, which surely is going to work at the top with these clues at the top. 3 cells, the maximum they can be is 398. Which is 20. If you had an 8 here, you'd have a 6 here, you'd be adding up to 39 exactly, which is not double 20. It's very close, but it's not double 20. If you had a 9 here, it would be 45, so that's nonsense. So I think this has to be a 3-7 pair. Yeah, if you had a 7 here, it would be in the 789 triple with a 6 down here. Sorry, if you had an 8 here, it would be in the 789 triple with a 6 down here. It would be 39. That's not possible up here. So it is a 3 and a 7. And the 7, 3 has to add up to, at most, well, The 7 is in a 7, 8, 9 triple, so is opposite the 6. The 3 is therefore opposite an 8 down here. And now the most it can be is 3, 9, 7, which is 19. So the most the other side adds up to is 38 in 7 cells. Oh, that's quite easily done. But this is, well, the one above 6 here is definitely odd. That's not very helpful. But let's have another go at now. This is 7, 8, 9 with a 6 here, and this might break somehow. If that's 7, 8, 9 with a 6 here, and it has to add up to, the 7 have to add up to no more, well, an even number that's no more than twice 19. So an even number below 40, leaving an odd number here that adds up to no more than 15. No, that adds up, totally wrong, that adds up to more than 5, well, which it obviously would. That's annoying. Mind you, if this was the odd number, it could only be 3 or 5, which is interesting. In fact, these numbers are from, just noticed, if we've got 8, 6, 9 there, 1 and 2, 1, 2, 7 here, these are from 3, 4, 5, and that's a triple. Good grief, I hadn't seen that. So we've got a 6, 8, 9 triple in the box as well. Ah, so if that was 9, 8, 7 up there, then you'd have to put 6 in both of those cells. So the 9, 8, 7's over this side. Why didn't I see that before? Right, 7 there with 8, 9 below it. 6 down here, 8 here, that gives us 3 up here. This now makes 42. This 6 makes 21. That works. Now, this can't be an 8, so look at that. Now this can't be a 6, and it can't be an 8. That is a 4, which gives us a 5 here. This is now a 7, 8 pair. What is this total? It is one of two possible things, 15, 20, 24, 31 or 32. And this group has to be one away from 31 or 32. And we said that this is either 28, which it is not, or 31. This is 31. This is 32. That's an 8. And this is going to be 31 or 32 in, well, it's got to be more than 4 cells to be 30. What is this? Remind me, 23, 27, 32. This has to be at least 31, which has to be more than 4 cells, but it can't be a 5. I think 8 is too high, isn't it? If it was 8, it would be at least 36. So that's a 6. Wow, okay, and there's no 5 in these two. Let's just get rid of the corner marks, and we can even do that here where we now have a 1, 2, 5 triple. Now up here we have from 1, 2, 3 and 5. There's definitely a 3 there. That 3 is looking at this cell, so 4 and 3 are resolved here. Oh, and this clue is nearly done. Right, that had to be odd, didn't it? So these now add up to 45 minus 7 or 11. So they add up to 34 or 38. So these 3 add up to 19 or 17. And these two add up to 14 or 16, which is either 9, 5 or 9, 7. Definitely includes a 9 and finishes box 9 for us. Good grief. Now, this, being a white dot, needs an even number on it, and that can't be 4, 6 or 8, so it's 2 with a 1. This is going to be 5, 7 or 9. No, not 9, because we know that 9's in one of those. Good Lord. So, either this is 9, 5, in which case 17, this has to be 34, that becomes a 5. So there's either a 5 there and a 5 there, or there's no 5 here and no 5 there. So 5s in these positions are kind of tied together. This is absolutely crazy, this puzzle. So 6 cells here have to add up to something one away from, I'm just going to do it again, 32. So 31 or 33 in those 6 cells, leaving the outies to be 12 or 14. That's unfortunately all too easy to do in almost any way. Right, let's do some Sudoku. 9 and 3, they have to be here in this box. That's handy. So this is a 1, 4, 8 triple. These are from 2, 6, 5 and 7. Now, what about this black dot? Surely 1 is nonsense, because that would have to be with a 2, yes. 9 would make a 45, which is too big to be odd, in the sense that it would have to be the larger number. So that is a 3. Surely a 3 can't go with an 8. The minimum of 8 is 36. Ah, well, the maximum of 3 is actually 20, but the maximum of this 3 is now 13, so that must be a 4. Wow, we're actually getting traction. I can't believe this. This puzzle is extraordinary. Now, those 3 add up to somewhere between 8 and 13. So these 4, I think they are necessarily going to be bigger than 13. Yeah, the minimum is 15. They add up to somewhere between 15 and 28. 8 to 13, 16 to 26 for the sum difference. But at least we know there's a 3 there and a 4 there. So this is a 9. Hasn't fixed this or those. It's difficult. And I mean, I've only got 2 or 3 clues left to use for anything. Maybe the possibilities are limited, although I don't think they are. There's a lot of flexibility in this sum, 4 plus those 3. As I said, it could be 28 by being 8, 9, 7. Then this would have to add up to 14. Actually, it can't do that. That's too many. But I just think there's too many possibilities to work on. But on the other hand, where am I going to go? How am I going to use this at the moment? Oh, this is tricky now. I mean, this is classic Spartacus. You get a certain way, and then you realise you have to completely think differently all over again. I don't think this white dot has been brought down at all in terms of the possibilities. If that was a 4, then this would add up to 8 or 9. This would have to add up to 16 or 18. I don't think it can do that. 4 plus 2 plus 5 plus 8 is 19, and that's too many. So this isn't a 4. Let's keep going with that. 3, 5, 1 is 9. 3, 5, 2 is 10. So can this add up to 20? I don't think it can do that either. 8, 5, 2, 4. 9, 5, 2, 4. I was going to say the 5 and the 2 can't be increased by a single 1, but the 9 can. So 9, 5, 2, 4 sitting above 2, 5, 3 would work. And I think above that, if we had a 7 here, we'd have 11 or 12. There's probably all sorts of ways of making 22 and 24. And with an 8, we'd have 12 or 13, 24 or 26 up here. Yeah, that's not so good. This is getting harder now. I can't really do eliminations on those numbers. It's a pity. What about these then? Can I really use these? This can't be 9, 8 or 7 or 3. Can't be 1 either, because you can't have a 2x sum number. So you couldn't have a 1 as one of the whites outside there. So neither of those are a 1. This one can't be 9, 8, 7 or 3 either. So it's 2, 4, 5 or 6. It's not that many possibilities. Probably too many to experiment with, sadly. Oh, this is a struggle now. Right, if that was a 1, 2 pair, then we'd have a 1, 2 pair here. This would be 3 or 5. Well, it can't be 3. It would be a 5. 3, 8, 1 and 7 at a minimum is 16. 2 and 8 at a maximum is 18. I think 16 is the maximum. Oh, and it's 3 cells I'm adding, so I don't know what I'm talking about there. Not 4. I was doing it as though it was 4. So if that was 1 or 2, we'd get a 5 here. That would also be 1 or 2. I don't see how I can use that. If one of these was a 6, it just doesn't have any bearing on this sum of 4 and 3 here. Now there's either 5s in both of those places or in neither. If there was a 5 in neither, there'd be a 5 here and a 5 in one of those two. That's not buttering any parsnips. 3, I suppose, in this column has to be in one of those two, because in this column it's in one of those two. Now we can't have a 1 here, so again 2, 4, 5, 6 or 8. I'm not even going to put in 9 as a possibility, because if that added up to 45, you can't get 44 here. 8 would add up to 42 down here, and there's no way of getting 6 to add up to 41, so that's nonsense. So both of them are 2, 4, 5 or 6, right. So if either of them were 2, the maximum is 11, and then the other one would have to have a 4. Could it get to 12 with a 4? Yes, it could, or even 10. If this was a 2, we've used 7, 8 and 9 in the box, haven't we? So if it was 2, actually the maximum is 8, 2 and 6. And then the minimum, including a 4, would have to be 9, and that's not possible. So we can rule out 2 from both boxes, both cells. They are 4, 5 or 6. Now I think once we've done that, we are probably stuck. I don't see how we can make further deductions. 4 and 6 could easily go together in this white dot world. Now neither of these can be a 9. Why don't I remember this information? That is useful because I know where 9 goes in the top row now. It's got to be there. 9 here would make one of them 45, which would have to be twice the other. That is nonsense. So we get a 9 there. Well, neither of these can be a 1 either, because 2 is not a possible number. So 1 is there. And now things have just got interesting, because there's got to be an 8 in one of these cells. And that means the total is either 40 or 38. The total of the other is either 20 or 19. And it can't be done with a 2. And it could be done, can't be done with a 6. So 8 or 8 with 4 or 5, and that's a triple. We get a quadruple rather. We get a 2 there. I didn't see that coming, but okay. Now, one of these is 8. So, what am I saying? 40 or 38. And the other one is 4 or 5, giving 20 or 19. If it was 5, then the outies would have to add up to 25 or 26. 7928 would get there. Wow, I think it would have to be that. I think it would have to be that. Wow, well, there's more deductions available than I'd realised. Oh, look, 8 there has given me 9 and 8 here. I didn't even do that. That gives me 9 here, not in the next cell. 4. It hasn't fixed this white dot at all. Oh, but this 4 is now really quite limited, and this has to be even in total. 17, 21, this is odd. 28 or 24. So these 3 add up to 14 or 12. And this isn't a 5 or a 7. $14 or 12. It could be a 7. It definitely adds up to 12 though. It can't add up to 14. So this lot adds up to 24, and that is a 5. Wow. This is doable. I mean, my goodness, it's crazy, but it's doable. Right. So these add up to 12, and these two add up to 9, and there are 2 ways of doing that, frustratingly. Now, this can't be a 5 anymore. Is that all I've learned? This is either 7-2 or 1-8. This can't be a 5. Goodness me. The deductions that come out of this are just incredible. It's so clever. You wonder how a Spartacus sits there and comes up with it. You really do. That is 1, 2, or 6, because it can't be 3 or 7. Now, should I focus? I don't think these are useful. It's these. One of them is an 8, so it adds up to 40 or 38. The other one is a 4 or a 5, adding up to 19 or 20. Frustratingly, I am going to have to pause this now and get my daughter. I'll be back. See you shortly. Right, so I'm back. I have parental duties, but I am aching to get back to this puzzle and find out what's going on. Now, where was I? I was looking at 8s and 4s or 5s down here. The 8s are 40 or 38. So the 4s or 5s are 20 or 19. And if it was a 5, that would be very helpful, surely, because that would be a big number. But if it was a 4, maybe the possibilities in this box are limited. 8, 9, 5, 4. The trouble is they're not very limited. I can't see a way to get that resolved. Ah, hang on. I found out there wasn't a 5 there. That was relevant here, wasn't it? I'm sure that means that this is a 1, but let me just check the maths. These add up to 19. These have to add up to 38. These have to add up to 7. That's a 1. That is what it means. Right, so there's no 1 there. That's a 2, 3, 5 set. So 9 and 8 are in this group of cells. Ooh, and that feels like it could be significant. So, if the 6 was this side, one of these is a 6. If the 6 was this side, this group of cells would add up to 30 or 33. But then 4 or 5 here would add up to less than 28. And that's not possible. So that is not the 6. This is the 6. That is a helpful 9 or 8 to get. Brilliant. So 6 there. Now, these 6 now add up to 26 or 21. And these 4 or 5, therefore, 26 or 21. These 4 or 5 have to add up to something within 1 of... That's much harder to sort. Oh, there's now a 6 in this group of cells as well, in one of those two. So, actually, let's put in these as a triple and remove the pencil mark. They're the corner marks. That's a 1, 4, 7 group. Right. These are from, that's 2 or 3. That's 2, 3 or 5, I reckon. That can't be 6 anymore, of course. Now, so this 4 or 5, that can't be a 6 either. Right, so these cells, if that was a 5, these would be 2 and 1. That would be 8. We'd definitely have the 6 to add in. That's 14. And either 8 or 9, 22 or 23. The 6 here... 22 or 23. The 6 here add up to 45 minus 17 is 28. Minus 3 could be 23 or 26. What did I say the 5 would add up to? 23 or 26 in column 5. 8, 14. Oh, 22 is possible, and 23 here. Well, that's quite likely. What about 4 of these then? 4 of these can only add up to a maximum of 4, 5, 2 is 11, and 9 is 20. And 6 of these have to add up to 12, 18, at least 23. So that is not a 4. That is a 5. Closing in now. Closing in now. That's a 4, 8 pair. That's not 5. This is a 2, 1 pair. So I can also fill in 3 and 5 in box 2. Right, and let's just check this out again. So, in fact, we can do those, 2 and 5. So 17, 19 to come off. That's 26. This has to be 25 or 27. We've got 8 there. This has to be 17 or 19. Oh, no! Oh, no, don't... Oh, I've got 2 5s up here. That's not helping. That one's meant to be a 4. Let me just rewind. Why did I not have a 4? Because I've got 4s in there. What's happened to 4 up here? I think I didn't fill 4 in as a possibility in this cell, and then I threw myself when I worked out this had to be a 4. I don't think it's changed the totals here. That can't be a 6. This is a 4. It can't be a 3 either. Yeah, that's right. Okay, let's do this properly. 4 there. No, that's the whole point. I've decided that's a 5 because 4 is too little. Yes, that's a 5. Right, so I'm still going to do that stuff. Now, 5 there. 4 in this column has to be here now. Right, this, the 5 has fixed the 2 and the 5. This now adds up, oh, this is different. 17, 22, that is 23. The 5 now has to add up to 22 or 24. And we've got 9. So the others have to add up to 13 or 15. Well, it's got to be 1, 6, 8, making 15, and that works, thank goodness. 1, 6, 8. So 9 goes here. 2 and 3 are a pair there. I don't think, I mean, that has done it for the white dot. I can't resolve it any more than that for now. Now, how about this? This is fixed. 17, 22, 26. Oh no, that's been fixed for ages. I'd forgotten that after I went out. Those add up to 10. They are either... No, hang on. 17, 22, 26. 13 here. Those add up to 10. They have to be 8 too. I don't know if I've actually should have known that for ages or not. 8, 2, 1. That's a 4, 7 pair. That's not a 1 now. This is not a 2, so it's 5. Wow. Let me just check this. 13, 26. Perfect. Now we've just got this black dot up here to go, I think. Oh no, there's this white. Ah, this is getting interesting. So this white adds up to 10, 19, 27, 32. This 6 now, 15, 20. It's got to get up to 31 or 33. So we need these to add up to 11 or 13. We must have a 7 there. Seven, 4, 2 would be 13, but 7, 3, 1 would be 11. Okay, so I can't resolve that yet. Ah, but this 6, 8 pair's been done. Good Lord, can't spot it. I've got a 4, 7 pair here now, so these are from 2, 3, 5, and 6. Now, this can't be a 6. So if there's a 6 on the white dot, it's there. And this can't be a 5, so it's either 6, 7, or it's 2, 1, and it's still not actually resolved. So I am going to have to look at this 4 or 8 thing, which is a shame, because that's feels complicated. Definitely a 9 in these cells. I'm still trying to avoid it, I have to say. That is 1, 2, or 7. So 8 is in one of these cells. That's hardly interesting. 4, 8, 3. If that was 2, 1, that's a 7. That can't be 3. Then these two would be 5, 5 there, and 6 here. But if it's 6, 7, then we've got 2, 1, and 5 place. That could be 2 or 5. That could be 1 or 2. And that could be also 1, 2, or 5. We're really going to have to work out the combinations of 4 cells. 8 cells, we know, can be either 40 or 38. So the 4 cells, and we now know it's 4, which I haven't known before, have to add up to 19 or 20 with a 4 in, and no 9 in this box. Ah, the most this cell can be is 5. And we have to get to 19 or 20, did I say? So the max 4, 5, 7, 9 is 25. That's plenty. 6 degrees of freedom. So this one can't be, well, in the column with the 4, this can't be a 4 or a 1. So this will be 7 or 9. Oh, this is tricky. This is tricky to concentrate on. I want a shortcut that helps. I can't, if I haven't missed some other clue there. Oh, this one. Maybe this will help. Okay, so I worked out that one of these, this needed a 7, this sum, so that can't be a 7. So it's 1 or 2. So this can't have 1 and 2 on its dot. Ah, 6 and 7 there. That can't be a 6. This can't be a 7. Is that interesting? I don't think so. These can't be 7s now. So wherever the 4 is, the 1 wasn't enough, so 4 goes with 9. These can't have a 6 in. So the 8 is going to make, we've done this a number of times and I still can't remember, 38 or 40. So the 4 is making 19 or 20 and it's going to go with a 9. 13 plus another 6 or 7 from these two cells. So it won't go with the 7. How are we going to make 6 or 7? 5, 2. Is that the only way? I think it is. 6 can't be done. 4, 5, 2, 9. So wherever the 4 is, it begins 4, 5, 2, 9, which makes 20. And then the other, it'll have 7 here. The other one will end in the 5. That's right. Okay, 4, 5, 2, 9, which will have, I'm just going to write it down in one column in corner marks. So I don't know which column this goes in, but one of the columns has 4, 5, 2, 9. It'll obviously finish 1, 6, 7, and it must have 3, 8 in. The other column, well, I know it begins with 8 and ends with 5, but I don't know which way around these columns are. How on earth is that going to get distinguished? Even this 6 thing isn't going to identify it, is it? So let's do this one again, though, just in case I've misunderstood how this works. I don't know how we're going to work out the difference between these columns. I really don't. But anyway, the 6, we've got an 8 to place in one of those cells. Now, I'm not going to be fooled by that pencil mark 8. So we need it to add up to 10, 19, 27, 32, 31 or 33. We've already got 20. The others add up to 11 or 13, which I thought could be 7, 4, 2 or 7, 3, 1. So it would either be 1, 3, 7, and that would become a 2, or if it was 7, 4, 2, that would be the 2, and the 4, 7 could be either way round. So these can't be 1 or 2 because they're going to get used up between that sum and that cell. They can't be 9, 5, 6 or 7, so they're from 3, 4 or 8. I'm really struggling to see how we can possibly disambiguate these two columns. Oh, this clue. Oh my goodness, that stretches into there. 14, 20, 24, 32. And this one currently adds up to 22. It must be 31. That's a 9. There we go. I've put the pencil marking in the right column, which is handy. I can just complete that. 3, 9, 2, 5, 4. 8 at the top of the other column, 5 at the bottom, and that black clue now works. Still haven't made this clue definitely work, but hopefully we are closing in now. 2 comes out of all of those cells. 8, 2, 9, 5. 5 comes out of those. 9 comes out of that. 8 comes out of that. 7 in this column must be here. In fact, that is a 1. Right, we are getting there now. 2, 3, 8, 3, 7. This must be 6 and 4 with a 1 there. This is Sudoku. I can do that. I will do the maths on the white dots at the end, probably. That's a 2, that's a 5, that's a 2, that's a 3. It says it looks good to you. Now, what does this add up to? This is 32, I think, isn't it? 17, 23, 27, 32. And this, please add up to 31 or 33. 9, 10, 25, 31. Wow, 31, 32, and 31 again. That is such a good puzzle. That is absolutely mad. Brilliant stuff. That's one of my favourites this year, definitely. Really clever Kropki X sums. Bit of a head wrecker. As I say, I will try and provide you with alternative grids to solve it in case you want to write something in cells outside. But wow, I really enjoyed that. Thank you so much for following through with me. I hope to see you again soon on the channel. Do subscribe if you've followed this far and you have a chance. Thank you for watching. Bye for now.